applications of set theory. So, under applications of set theory, we are discussing about the part 2, which is under the advanced level. So, here under this part 2 advanced level, the set theory application is of n of A union B union C is equals to n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of C intersection A plus n of A intersection B intersection C. So, here let A comma B and C be any three sets. Then we have n of A union B union C is equals to n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of C intersection A plus n of A intersection B intersection C. So, here based upon this principle, let us perform one example. So, here example in which out of a group of 70 students, say a total number of students or the total strength of a class. Out of 70 students, there are of 70 students in a class. Out of these students, it was found that 25 students play basketball, and 30 play football, and here 24 students will play kabaddi, and 10 play both basketball and as well as football. So, here 10 students play basketball and football. Nine play basketball and kabaddi. So, there are of 9 students who play basketball and kabaddi, and 12 play kabaddi and football. So, there are 12 students who play kabaddi and football. Five play all the three games. So, there are 5 students who play all the 3 games. Then we have to find out the number of students who play none of these games. So now the solution starts. So in our solution, as per the problem, the total number of students in a class, that is the total strength of the class, is given by means of 70. So here let us write it as total number of students in a class is given by means of 70 as per the problem. So here total strength is given by means of the universal, that is the universal set. So here we can write it as, so here this is in the sentence form, I want to write in the mathematical form as per mathematical statement. So it can be written as number of students given by means of n of, so here total strength is given by means of the universal set, that is mu, is given by means of the number is of 70. So here in this manner total strength is given by means of n of mu, that is a universal set, is equals to 70, that is the total strength of the class. Then now as per the problem, so here 25 students, 70 is the total strength, that is n of mu is equals to 70, then 25 students are playing basketball and our students are playing the basketball. So here I want to write the basketball by the abbreviation, that is B, and the football by means of F, and kabaddi by means of K. So here 25 play basketball. So here as per the problem, 25 students are playing the basketball. So here number of students who play basketball is of 25. So here I want to write the basketball football and kabaddi, these three games, by means of the abbreviations, that is, since it is of basketball, the first letter is of B, so I want to write it as B, football by means of F, and kabaddi by means of K. So here number of students mathematically we can write as n of who play basketball, so n of B is equals to 25. So n of B equals to 25 gives us the number of students who play basketball equals to 25. Then similarly as per the problem, so here 30 play the football and 24 play the kabaddi. Number of students who play football is given by means of 30. So mathematically we can write it as n of football by means of F is equals to 30. And at the same time number of students as per the problem, the number of students who play kabaddi is given by means of 24. So mathematically we can write as n of number of, that is n of students who play kabaddi, that is by means of K, so equals to, they are of 24 in number. Then now as per the problem, 10 play basketball and as well as, there are of 10 students who are playing basketball and as well as football. So here number of students who play basketball and football is given by means of 10. So, we can write it as n of number of students who play basketball. So, here B, but here and. So, here and indicates say who are playing basketball and as well as football. So, here and indicates intersection. So, here and is given by means of intersection. So, here B intersection basketball and, that is intersection football, by means of F is given by means of 10. Similarly, as per the problem, 9 play basketball and kabaddi. So, here number of students who play basketball and kabaddi, they are of 9 in number. So, mathematically we can write it as n of number of students who play basketball by means of B and by means of intersection. So, here and indicates again here intersection, then now kabaddi by means of K, number of students who play basketball intersection, that is and kabaddi. So, basketball and kabaddi, they are of 9 in number, that is equals to 9. Then now as per the problem,